The cloud has revolutionized the way we build and manage networks. AWS offers a comprehensive suite of networking services. One of the most powerful tools in this suite is AWS Transit Gateway. It acts as a central hub, simplifying network connectivity between various components of your cloud infrastructure. At its core, AWS Transit Gateway is a service that enables you to connect your virtual private clouds and on-premises networks. It acts as a transit point, eliminating the need for complex peering relationships between individual VPCs. Imagine it as a central traffic controller, streamlining the flow of data within your AWS environment. Transit Gateway supports a wide range of AWS services, including Amazon VPC, AWS Direct Connect, and AWS VPN. This makes it an ideal solution for organizations of all sizes looking to simplify their network architecture and improve overall network performance. Before we delve deeper into Transit Gateway, let's take a moment to understand virtual private cloud routers. These routers are the backbone of your VPC network, responsible for directing traffic between subnets within a VPC and to external networks like the Internet. Each VPC comes with a default router, but you can also create custom routers to meet specific networking needs. These routers use route tables to determine the path for network traffic. Each route in the table specifies a destination and the next hop for traffic destined for that destination. VPC routers play a crucial role in connecting your VPCs to the outside world. They use network address translation to allow instances in private subnets, which don't have public IP addresses, to communicate with the Internet. Source network address translation is a critical function performed by VPC routers. It allows instances in private subnets to initiate outbound connections to the Internet without having public IP addresses. When an instance in a private subnet sends a request to the Internet, the VPC router replaces the instance's private IP address with its own public IP address. This process is called SNAT, and it ensures that the response from the Internet is routed back to the correct instance. SNAT offers several benefits, including enhanced security by hiding internal IP addresses from the Internet, and cost savings by allowing you to use a smaller number of public IP addresses. Traditionally, managing SNAT for multiple VPCs could be complex, requiring careful configuration of route tables and NAT gateways. However, AWS Transit Gateway simplifies this process significantly. With Transit Gateway, you no longer need to configure individual NAT gateways for each VPC. Instead, you can enable SNAT on the Transit Gateway itself. This allows instances in any VPC connected to the Transit Gateway to initiate outbound connections to the Internet. Transit Gateway's centralized SNAT management offers several advantages. It simplifies your network architecture, reduces management overhead, and improves performance by providing a single point of control for all outbound traffic. Section 5. Connecting multiple subnets. One of the primary use cases for AWS Transit Gateway is connecting multiple subnets across different VPCs. This allows you to build complex network topologies and segment your workloads for security and performance. To connect subnets to a transit gateway, you create attachments. An attachment acts as a bridge between the transit gateway and the subnet. Once the attachment is created, you can then configure route tables to direct traffic between the subnet and the transit gateway. Connecting subnets to a transit gateway is a straightforward process. However, it's important to carefully plan your subnet architecture to ensure optimal performance and security. Section 6. Real-world scenario, streamlining network traffic. Let's consider a real-world scenario to illustrate how AWS Transit Gateway can simplify network management. Imagine a company with multiple departments, each with its own VPC. The company wants to allow these departments to share data and resources securely. Using Transit Gateway, the company can connect all of its VPCs to a central hub. This eliminates the need for complex VPC peering relationships, simplifying network management. Traffic between departments can flow securely through the Transit Gateway, and the company can easily control access to resources using security groups and network access control lists. Section 7. Key considerations for subnet integration. When integrating subnets with AWS Transit Gateway, there are several key considerations to keep in mind. These include subnet size, availability zone placement, and security. Subnet size is important because it determines the number of IP addresses available to instances within the subnet. When connecting subnets to a transit gateway, it's essential to ensure that the subnet has enough IP addresses to accommodate current and future growth. Availability zone placement is another crucial consideration. For high availability, it's recommended to deploy your subnets across multiple availability zones and connect them to the transit gateway. This ensures that your applications remain accessible even if one availability zone becomes unavailable. Security is paramount when designing any network architecture. When connecting subnets to a transit gateway, you can use security groups and network access control lists to control traffic flow between subnets and to external networks. Section 8. Exploring additional transit gateway features. In addition to its core functionality, AWS Transit Gateway offers a range of additional features that enhance its capabilities and make it a versatile solution for a wide range of networking needs. These features include VPN connections, AWS Direct Connect integration, and Transit Gateway peering. VPN connections allow you to securely connect your on-premises networks to your AWS environment through a transit gateway. This enables you to extend your network to the cloud and leverage AWS services while maintaining a secure connection to your existing infrastructure. AWS Direct Connect integration enables you to establish a dedicated, private connection between your on-premises data center and your AWS environment through a transit gateway. This provides consistent, low-latency performance for demanding workloads and applications. Transit Gateway peering allows you to connect two transit gateways in different AWS accounts or regions, enabling seamless communication and resource sharing between them. Section 9. Integrating Cisco Catalyst routers with Transit Gateway. For organizations with existing investments in Cisco networking equipment, AWS Transit Gateway seamlessly integrates with Cisco Catalyst routers, enabling you to leverage your existing infrastructure while benefiting from the agility and scalability of the cloud. Cisco Catalyst routers offer a wide range of features, including advanced routing protocols, quality of service, and security capabilities. By integrating Cisco Catalyst routers with Transit Gateway, you can extend these features to your AWS environment and build a robust, hybrid network architecture. Section 10. Conclusion, Benefits and Best Practices. AWS Transit Gateway is a powerful service that simplifies network management, enhances security, and improves performance for organizations of all sizes. By centralizing network connectivity, simplifying SNAP management, and offering a range of advanced features, Transit Gateway enables you to build robust, scalable, and secure cloud networks. When implementing Transit Gateway, it's essential to follow best practices such as careful subnet planning, availability zone deployment, and robust security configurations. By leveraging the power of Transit Gateway and adhering to best practices, you can optimize your AWS network infrastructure and focus on what matters most, your business.